In this video, we are going to go through the rocker assembly. So this lesson is introducing a brand new component of Inventor called assembly files. So up until this point, we've only done part files and drawing files. Starting this lesson and for the remainder of the semester, we are mostly going to be working with assemblies. So what is an assembly? An assembly is a component that is comprised of two or more individual parts, and these parts are constrained to interact like you would imagine them in the real world. So imagine this part in the real world. You have a web plate and a few different links and some pegs, and then this can move as like a gear arm. And in Inventor, we are going to simulate those constraints to be able to mimic that motion. So we're going to be making a bunch of individual parts and then combining them in an assembly. So how do we make this? Well, we start by doing what we've been doing all along, is that we create a part first. And we're going to create a brand new part file for every single part that you see here. So how many parts do we have? Well, we have a web plate, we have a drive link, a center link, a rocker link, and then I see 4 pegs. However, we only have 2 different size pegs, and then we have 2 of each of them. So this is a peg right here, and this is a peg right here. So I see 6 total parts. So we're going to start this overall component by drawing and creating 6 individual part files. And the part files are actually going to be the easy part. We easily know how to draw any of these. Once we have all 6 parts drawn in different files, we are then going to open up a 7th file, an assembly file, and we're going to bring all those parts into it, and then we are going to connect them. So we're going to start by drawing the 6 parts. So again, we're limited to 15 minutes per video, so this one will probably take 2 or 3 videos to make, but we can probably do the parts pretty quick. So let's start by doing the drive link. So the drive link right here. Where's the drive link? Right here. Okay, so we are going to create a new metric. We're doing metric this time, so standard Inventor part file. And I would start this by doing a center to center slot that goes 30 apart, and then the overall height would be how much? Not 10, but actually 20, because the radius is 10, which makes the diameter of this semicircle 20. So let's see if we're back loaded. All right, so I'm gonna do a new sketch, don't care which plane. Hit down the rectangle one to get the center to center slot. Don't do the center point one. I think people often make that mistake. Start here, go across 30, and then go up a height of 20. And then we have 2 circles at each center with a diameter of 10. So circle, diameter of 10. And then when you try and pick it, sometimes it doesn't appear right away. You do see the green dot right there. If the green dot does not appear for whatever reason, hover over the arc and then the center will highlight. And now you can do it. Okay, so that's actually it for the sketch. Not bad, right? So finish the sketch, and we are being extruded 5. It says it's 5 millimeters thick. So extrude, click it because it doesn't know which one you want. Do you want the holes? Do you want this part? And we want this to go 5. And there we go. Okay, now we also want to make sure that we give this the right materials. So the correct material for this is SAE 1040 steel. I don't know if they actually have that oddly specific of a steel. No, so I don't care that much which one you do. Just do a steel, because then you're showing me you know how to change the material. So we'll just call it straight up steel. Actually, that one's kind of ugly. Let's pick a better looking steel. Okay. Whatever. Okay, so the next thing we want to do before we're done saving this part is I want to name the parts. So we know that the part is called drive link, and then it also has a part number for like manufacturing purpose of this AM31122A. So I'm going to show you how to do that now. And this is an important step, and you'll find out when we do the drawing file later on. So we're going to first start with the part files, then the assembly file, and then we're going to do a drawing file. And it's important that we're labeling everything right when we create the part, because when we go do the drawing file, many minutes later, it's important that everything will be properly identified when we do things like, schedules and bill of materials and quantity orders and all that good stuff. Okay, so we're going to go to iProperties. I can't remember if we've done iProperties yet, so I'll show you how to do it. iProperties is where you're able to give the information of the physics and the geometry of the part you created. So to get to iProperties, there's two ways. I'll show you both. You can go to File, iProperties. That's one way. Or you can right-click the part. I haven't named it yet, so it's still called Part 1. Right-click and iProperties. Once you're in iProperties, there's different tabs over here. The physical tab is one that we are often working with, and the physical tab will tell you what material you have, and we changed it up here, but you could have changed it over here as well. And then once it has the material, it knows what the density is, and Inventor can calculate the volume of this, so it can tell you things like its mass, its area, its volume, its center of gravity, all that good stuff. It doesn't really matter for this project in this course, but it's kind of cool to know what you could do with Inventor. Which tab is the one I want? Oh, I forget. I think it's Project. Let's try Project. If I'm wrong, then, well, I'll have to probably edit this out. So if you're listening to this, that means that it worked. Okay, so we're going to call the part number, what we see over here, AM311-22A. So AM-311, what did I say? I have awful short-term memory. 311-22A. And we'll call the description drive, let's make it all caps, drive link. Okay, so I'm going to do a file, save as, and I'm going to create a whole folder because we're going to have so many different files, and I'm going to call the overall folder Rocker Assembly. And then I'm going to save this inside that folder and call this the drive link. Okay, so we are done with one of them. And now I'm going to do the other ones quickly, but hopefully we can do them much faster since I don't think I need to talk through as much. So new, standard right here. And one thing that you could do is instead of doing a brand new file, you can do file save as and then edit the other one. I'll show you what I mean in a minute. All right, let's do the rocker link. So the rocker link is a center to center slot with a length of 100 and a height of 20. Again, with those holes, the 10 diameter holes on either center. And then we have another center to center slot offset 15 from the original center. Okay, so let's do a new. I think this one's probably a better plane to start with. Center to center slot. 120, 10, another 10, and then we have another center to center slot. So I'm just going to put it somewhere and then move it with dimensions later. I think it was 70. And then probably 10, but let me double check that. Yeah, 10. And then I'm going to hit escape, and then I'm going to hit dimension, and I'm going to tell it, okay, the distance from this center to this center is 15. And we are good. So finish sketch, extrude it up, and that's distance of 5. And we are going to do another steel. And let's change the color. You'll see why later, but it's going to help if they don't all have the same color. Let's make it a beautiful sky blue. And the color doesn't really change the physics of the part. The part is still made out of carbon steel. It's just in aesthetics. Okay, we're going to go over here to eye properties, change the part number, AM311-2C. And the description was, which one was this? The rocker link. File, save as, and this one is the rocker link. Okay, now we're going to do the center link. And you should notice that the rocker link and the center link have the same geometry, just different dimensions. So instead of doing the whole thing over again, what I'm going to do is this. I'm going to do file, save as. And by doing file, save as, when I already saved the part, I'm essentially making a copy of the rocker link. And now that I made a copy of the rocker link, let's call it center link. Now I could edit this, and this is now the center link, and this is not affecting the rocker link we just did. So now I can go ahead and edit this to turn this rocker link into the center link. And that should be a fast way of doing it. So this one has a distance of 90, 50, and then 20, and everything else should be the same. So this one should be 20, this should be 90, and this should be 50. Boom. Just like that, we updated it. Let's change the color. Don't care which color you use. You don't have to do it with the ones I did. And let's edit the eye properties. So this one is center link. And we'll call the part number AM311-22D. Hit OK and save it because we already named it. Okay, awesome. So we have about a minute and a half left for this video. We can do the pegs real quick. If we don't finish both of them, then we'll do it on the next one. But the pegs are going to be really easy. The pegs are just a cylinder. One with a diameter of 10, extruded 10, and then the other one also has a diameter of 10, but it's extruded 15. Do we see that somewhere? Yeah, over here. And then they're made out of nylon. So for that one, I'll do a brand new part. And we'll do here a circle, diameter 10, extruded, one was 10. We'll change the material to nylon. I don't care which nylon you use. And change the eye properties. Let's call the part number. Does it have a part number? No. So we'll just name them both peg 10. Okay. And then we'll do a file, save as. We'll call that peg 10. And that'll be it for this video. In the next one, we'll do the peg 15, the web plate, and then if we have time, we will start the assembly.